For the React JavaScript library. I am going to be coming from a perspective of a JavaScript developer, so I'm going to assume that basic JavaScript syntax and logic is something that's already known, and I'm just going to be approaching it from that position here. First things first, who am I? My name is Alex Rau. I'm a front-end software engineer and a recent graduate of the Turing School front-end program. I'm a React enthusiast. I am also an enthusiast of actually testing code and making it stronger through that. And I just like learning new things in general. So not limited only to React, but all things JavaScript and beyond, really. Initially, for this talk, I'm going to be going over React basics. I'm going to be just to give you a basic understanding of React, what it is, and kind of how the context of everything works together. We're going to be going over the concept of the virtual DOM and basic constructions and relationships with React components. Going to be going over state and props, which is how React stores and deals with and handles information inside of a React application. Going to be going over lifecycle methods, which are specific to class components, and there are built-in methods that can be used. Conditional rendering, which React lets you do, to where if information changes, we can render a different version of that part of your website. I'll get into that when we get to that part. Component relationships, how they communicate to each other and where they live in each other in association with DOM. I'm going to be going over building out and spinning up a basic React application using the boilerplate that Facebook provides us, and I'm going to be going over basic concepts and a little bit of syntax with testing with the Enzyme and Jest libraries. What I'm not going to be going over, just because this is a basic overview, I'm not going to be going over advanced state management with the Redux library. I'm also not going to be going over React hooks, which is actually the newest React release 16. It's built into React now to do advanced states management. Some people think that can replace Redux as well, but those are both definitely really fun things to play around with if you get further into React. There's a React router, which is a dependency that allows a React application to handle routing, which React does not do on its own, as that's a dependency and not just basic level. I'm not going to be going over that. As for React testing, React actually has a React testing library, which is also newer to write React tests. But my primary experience is with Enzyme and Jest, so that's what I'm going to talk about here. And React Native, which is a version of React they built to build mobile applications with React, which is actually really fun to play around with. And I recommend if you get the time for that. Now, I am going to warn you, this is going to be a bit of an info dump. I have 50 minutes to talk, and I'm going to get into some deep level things with just React, try to give you an overall context of how everything relates to each other. But bear with me, this stuff is really cool, and I hope at the end of it that you're going to have an understanding of not only what React is, but kind of how it works. So here's some history of the React framework itself. It was initially created by a developer at Facebook named Jordan Walk. It was inspired by XHP, which is an extension syntax that Facebook also developed for PHP. To build on top of a PHP app, he was inspired by that and actually built it out with JavaScript. And it kind of works similarly, which is why you hear React referred to as a library a lot, and not necessarily a framework. It was first used when Facebook implemented it in its newsfeed in 2011, and other than that, Facebook was not built fully in React. It was just used for the newsfeed. The Instagram actually picked it up in 2012, and the initial release of the full library, where you could build an app fully in React, came out on May 29th of 2013. There have been updates since then. We are now in a version of React 16. I don't offhand remember which exactly number it is, but what exactly does React do? So first I'm going to start by talking about the most important concept of React, which makes it different from all other JavaScript frameworks and websites. It's the idea of the virtual DOM. Now, anyone who's built a JavaScript application will build out their HTML skeleton, have CSS for styling, and then add in JavaScript to deal with user interactions, make the site, do stuff basically. But your DOM that you're manipulating is your HTML build out. Now what React does is it has a version of the DOM, but then React, when it's rendering the application, will actually render a new version of the DOM virtually, which we call the virtual DOM, and it will compare it to what's actually printed on the page. And if nothing's different, then React won't render anything or do anything, but if the virtual DOM, say, has this change that I've made to this one, when it re-renders, it'll compare to what's already on the screen, and it will only render what needs to be changed. It will not actually render the entire page. This is what makes React powerful. It can react to user changes a lot quicker because the page doesn't have to go through a full refresh just to change one little bit of information and everything else stays the same. And React is built specifically for that. And it does this via a syntax called JSX. Skip ahead a little bit to talk about JSX. Here's an example of JSX. All React components act like a function, and all React components have a return statement which provides JSX. JSX looks a lot like HTML, and it is incredibly similar to HTML. There are things which you'll see in later slides that tend to bring in some JavaScript and connect it to the overall component that it's added to, but ultimately JSX needs to have a container, one singular container around all of the meat of your component there. You have to sandwich it within one. A lot of people tend to use div, but you can use section, form, any HTML tag that's able to contain everything else that you want to put into it. And the parent component of any React application is the app component, which I have an example of here. This is comes built in from the React boilerplate as well. It's just called app, and every single component that you build out in React will live inside of app in one form or another, either as a direct child or as a grandchild to a child of app, but app is going to be the parent of every single React component. And the reason why is how this works. You have your front-facing public index.html. If you built out a regular app with JavaScript and HTML, you're going to have index.html is what displays to your page. And every React app has an index.html file that looks like this. This comes directly from the boilerplate, and it provides in the body a div with an ID of root. And then corresponding to your index.html file, you will also get a built-in index.js file, which grabs this root by its ID right here and just inserts app into it. And because once app is inserted in there and rendered inside of that div, everything that is inside of app will be rendered as well. And that's basically how React renders to the page. So you're not actually dealing with the DOM here. You're dealing with JSX, which is theoretical DOM created by JavaScript that gets rendered virtually and compared to what's actually on the page. And this is kind of how it all nests together. Now, React applications deal with information from user reactions, or let's say you're getting a fetch request from an API or anything like that, in two ways. It deals with state, or it deals with properties. Now, state is something that lives inside of specifically a class component. It acts a lot like a constructor function where it's going to construct an object. Inside of that object is sort of a store, which is another object where you can set any sort of keys you want with any sort of values. You can save information from user actions to your state and then reference it anywhere in the component that you need it to. The way you set state is from a built-in function from the React library called setState, which you have down here. This is handling a change specifically to an input, so if a user's typing in the name, it's going to grab that name from the event target and set that name to state. And then the other thing, besides referencing state directly in your app, you can also use that state or information on a fetch call or any other place you get information to pass properties down to children components. And that is what props are. Here we have a component called mentor card, which I'm rendering with two properties with the key of key, and then a value of UUID, which is a dependency I've used to generate a random number to assign to the key property of that element. just to make it distinct from all the other elements. I may be rendering this more than once, so you want to have a different key on all of them. And then I have another property here with the key of mentor, and then I'm passing them an object with some mentor information to print to this card. Now here's a snippet from that actual component. If we go into it here, you can see I'm just taking the name, current title, and background from that mentor that I passed down, referencing it there, and then I can put it into my JSX and print that information to the page. This is passed down. You can do that inside of a map, so you maybe can print multiple cards, one for each element in an array, if you have an array of objects or something like that. This definitely makes React components reusable. And if state or props change at all for a component, it will trigger a re-render for React, so React is always looking to changes to these things. Now, next I'm going to get into the two different kinds of components that are available in React. I mentioned class components before, but first I'm going to get into a functional component, which is basically just a function that returns JSX. That's all a functional component does. You can deconstruct props that are passed in and use them in your JSX. Also, like any other JavaScript function, you can put more functions in here to run as subsequent stuff to, again, edit your JSX. But ultimately, this component function is going to just return whatever you put here, and then it's going to print that to the page. The second type of component is a class component. This is a version of the component where it's no longer just a function. This actually acts, like I said before, more like a constructor function, where it's going to construct an object that has an inner method that will then render and return your JSX. It pulls all of the information from a object in the React library called component, so all class components are going to extend the component that I'm deconstructing in my import statement up at the top there. In this particular component here, you can see the constructor method is called. We pull in the super method so we can actually get the methods that it needs from its parent here. You can store the state inside of the constructor, so any information you want to come in there will be attached to your component object whenever it's built. And then there's the render method, which is actually going to render your JSX. You see you can deconstruct state and you can deconstruct props in your JSX or use them wherever else you need to. Functional components now with React hooks are also capable of dealing with a version of state, which is more of a global state. The Redux library also gives you access to a global state. So React is actually starting to move in a direction where eventually they will want to just have every component be a functional component because they render quicker and it saves time. But this is not being deprecated anytime soon. And it is definitely really useful when you're learning React to be able to write components out like this, so you can just kind of see how everything's working together and manage your information a little bit better, especially when you're learning. Now, all class components, because you're dealing with methods that are built in and firing at certain points in a component lifecycle, I'm going to talk about the component lifecycle. The way React components work is that the render function, which is rendering your component and building out your JSX, it fires continuously. So it's constantly building that virtual DOM to compare it to the regular DOM and then see if there's any changes. That process that I described before. And there's three main steps to this component lifecycle. The first time it's rendered, let's say there's nothing on your page and this component has been rendered out of nothingness and added to your page. That is the mounting phase, that first render that's creating it from nothing. Every other subsequent render where it's rendering the DOM again and comparing it to the original DOM, those are update phases. And then lastly, there's a phase called unmounting, which happens at the end of every single render. This one is specifically used for, say, if you're using some sort of function that's setting a limit, like setting a timer or something like that, there is possibility that if you're running a timer, it's not going to be done by the next time your app is rendering, so you can actually put functions in there to stop it, so it'll start new again every single time. But otherwise, you're not going to be using unmounting a whole lot, except for more advanced stuff, which admittedly I have not run into in my experience so far. But mounting and then updating are definitely things you're going to be dealing with all the time. with building a React application. Important lifecycle methods, again, these lifecycle methods fire whenever it hits that certain point in the lifecycle that it's at, and these come built in from that parent component object that you're extending to make your class. There's the render function, which renders your JSX. You can, again, like any other JavaScript function, put sub-functions inside above the return that you might want to happen before it actually renders your JSX and so forth. But this one gets fired continuously. There's the constructor of the function, which again constructs your component. This fires once at the beginning of the mounting. Once your component is constructed, it doesn't need to do that again. You can just continuously call render. And then super, which pulls the parent methods from the parent object. Another important component method that you will definitely use is a component did mount. This one happens at the end of that first render, and only at the end of the first render. It never gets fired again. If you're not using something like Redux middleware or something like that to do your fetch calls, this is definitely a great place to do a fetch call to populate your information for your component or your application. This fires once, and then you don't need to fire it again. As you can see here, I have 3 fetch calls that are actually going with this in this application I took my snippet from. Component did update acts a lot like component did mount, except it fires after every single update render instead of just once at the initial mount render. The only thing about component did update and the render function in general is that React will not let you set state in either one of them because they are called continuously. So that's just something to keep in mind when you're using these methods. And this is definitely something you will definitely see in the real world. This is used a lot. This is a component will mount, which fires, as you can probably guess at this point, at the beginning of that initial mount render. As you can see here, I was building out a tree that I populated with data for a autocomplete bar that I made. But this is being deprecated, so it's something that you probably want to use less when you're just starting out. Especially just trying to understand React, it is definitely helpful to have component will mount, and I don't think they're getting rid of it anytime soon, but it is definitely going away at some point, so it's one of those things you want to eventually work out of your code as you're learning, find better ways to populate that information. And also class components give you the ability to build custom functions that are fired by user actions. All the lifecycle methods are fired by a step in the lifecycle, which are automatically triggered whenever the application goes through that particular step. But if you actually want custom functions that are fired by a user action, you have to bind them to the particular instance of the class that's created. This is because React's class components are consistently rendered over and over again. Each version of this component that's being rendered is going to have its own definition for the keyword of this. So if you want to reference this dot whatever function that you're using, you have to bind it to that particular instance. When it renders a new one, that's a new this. So if React doesn't know which this you're referring to, it's not going to work. So originally with ES5 syntax, you would have the function built out normally like that. In order to bind it, you would have to place this little phrase here inside of the constructor function. Usually, conventionally, it'll go right under the state object, as I tried to convey in my snippet there, but I guess it's a little small. But yeah, you just declare the function and then bind the function to that instance of this, and it'll do that during every render. Or now that ES6 has come out, arrow functions actually automatically bind, so you no longer have to do an extra step to bind your functions. If you just write them as an ES6 arrow function, then you're good to go. It's automatically bound to that instance of this. Next,
can I jump in and ask a question?
Oh yeah, sure. Okay.
So, do you need to run Browserify or anything on that to get the ES6 functions working for a browser app?
I mean, I've used Babel to be able to compile down to ES5.
Okay, so you do need to run it through a transpiler.
Yeah, for browsers that don't handle ES6.
Gotcha. Okay.
For conditional rendering, this is another thing that React does that makes it very powerful. You can render different versions of your JSX depending on either state or props that are passed down. And there are 3 different main syntaxes for this. This one, if you've done regular JavaScript, you definitely see if-else syntax for a lot of things. You can use it again for JSX too, because it works just like JavaScript here. In this particular example, I have a property called count in my state that's going to be a number. If that number is less than 10, we're only going to render this version of your JSX with an H2 that asks if it's possible if you can count to 10, and then state your count and gives you a button that you can just add 1 until you get to 10. When you do get to 10 or past 10, it will then instead switch to this, the else case, where it declares that you have successfully counted to 10. And then it gives your state, the count in state, and the same button to be able to add it up to 1. Now the second version of this syntax is the short circuit operator. As you noticed in the last example, this span where it gives you the state count and this button where it gives you the ability to count up 1 don't change in either scenario. So this syntax actually allows you to just handle the H2 that does change. Either the state count is less than 10, then you print this, can you count to 10, or if it's greater than or equal to 10, you successfully have counted to 10. It'll print one or the other depending on what's in state. And an even shorter and more dry version to do that is, of course, a ternary operator, where your if case is declared by this question mark. If it's less than 10, otherwise you can count to 10. And these two elements, of course, stay the same. The ternary is my favorite version to use just for drying up my code, making it easy to read. And typing less code is always a good thing. But all three are equally valid. All three will definitely work. So it's a matter of personal preference at that point, which one you choose. Now, this is where I'm going to get into how React components interact with each other. And this is definitely another really important, if you're going to use React, a really important concept to understand. As I explained before, the app component is a component that is going to be the parent of everything else. That would be symbolized by this red parent over here. Every other component will live inside as a child. Those children components can have their own children. Here I have 2 childs and 2 grandchildren for each child. But the important thing about this component relationship is the fact that React sibling components cannot talk to each other. So this child and this child cannot exchange information, neither can the grandchildren. This child and that grandchild can also not exchange information. Information can only come from parent to child or child to parent. Now this is an issue, obviously, when you're trying to pass around information from component to component in React. And React actually gives you this concept to deal with that issue, the concept of data down, actions up. This is the only way that React sibling components can talk to each other. You would have to start with your parent component. You would have to declare a function within the parent component to handle any sort of information from that you want to use for like a user reaction, a user interaction, or something like that. Here I have declared inside the parent a function called handleClick that's somewhere beyond my snippet, but I am declaring inside the JSX a child component called currentMembersForm, and I'm passing that handleClick function down as a property with the key of clickfunc here. And then when we go into that currentMembersForm, it has its own function that I named handleClick, although those names don't have to match. You can name it whatever you want, but this one is specifically handling when a user clicks a button. When it clicks a button, it's going to grab this function from the properties that's been passed down, and it's going to call it and give it the information that this click collected. So got it in the event, I take that information, I send the event, I send the current member, which I got from state, and I send that string of current up to that function. And what this does is it takes the information in the child, it sends it up to the parent, and then fires that function in the parent with that information. When it does that, that makes the parent able to pass it down to its sibling. So that is the only way React is able to handle passing information from sibling to sibling. As an app gets bigger, or you're dealing with a lot of information, obviously this can get rather cumbersome. That's actually, again, where the Redux library or React hooks would come in very useful. They actually establish, again, a global state, which can be accessed by any component. All you have to do is connect it to the global state. So you would actually take that information and throw it in the global state, and then you can take it down. But if you're just building a basic level React app with no dependencies and no extra things, then this would definitely be how you do it. And I think this is a good concept to understand too, just when you're dealing with this, because smaller level React functions, like React components, like if you're building a form or something like that, you maybe don't need to add all the extra dependencies and declare a global state, and you can just do this real quick. It all depends on what you're trying to do, how big it is, and how you think the best way to do it would be. Another thing you also want to think about when you're building a React app is to avoid the concept of prop drilling. Let's say this yellow parent component has information that you want to get to this red grandchild component. React allows you to do this, and this is definitely something that's okay to do. It's not going to crash your app, but you would basically pass the information to the orange child and then down to the red child. The issue with this is the orange child ultimately doesn't need the information at all. It's just a pass through to the grandchild in red here, and that can again get cumbersome and confusing if you start dealing with scaling up your app, dealing with more information or adding more parts to it. You could end up in an issue where maybe you're passing through 2 intermediate components or 3 or 4. And when you're starting out, especially if you're building a smaller app, this is fine to do, but it's definitely something you want to try to avoid when you're building out your initial structure. Again, the Redux library and React hooks, by declaring a global state, make it so you can 100% avoid this. So when you get more into state management with either one of those tools, this is actually something that you don't have to worry about. But it's definitely, when you're starting out with React and you're building a base level React app, when you're building your structure, you just want to try to avoid this as much as possible, because it can become a problem again in the future. Now I'm going to actually get into building a basic level React app. I'm going to drop these slides in the meetup comments so you can have access to that link, but Facebook has a GitHub repo for a React boilerplate called Create React App. In the README, they actually give you instructions on how to pull this down on your computer and spin up just a React app locally. This gives you all the base level components you need to start just a React project, just be able to start at a beginning level and just start coding. I have some of them demonstrated through here. There are 2 main folders that you're going to be looking at as building out a basic level application. There's the public folder. Inside the public folder is the index.html file. As I showed earlier, that's the initial HTML structure with the root ID div, and that's the one that app and all your subsequent components get rendered into. Ideally, you're not going to touch index.html. The only reason I've ever had to add to it is if, like, I want to use a font from Google Fonts or something like that, and I have to put a tag in the header or something like that for my CSS. But otherwise, you're not going to touch HTML. But it's definitely good to know that it's there, and when a React app is rendering, that's the public-facing part that's put into the page. Everything else is going to live in your source folder, which is labeled as src. All of your components are going to live inside, ideally, for a file structure convention, it's going to live inside their own folder with the name of the component indicated. That's easy to read, easy to navigate. It's not something you have to do, but as your app gets bigger, that's definitely a lot nicer for other developers who would want to maybe come in and look at your code. But the Create React App boilerplate. Will give you initially your app.js file. It'll give you a CSS file, a test file for app. It'll also give you your index.js, which is the function that grabs the root div and prints app and all of its children into it, and a CSS file for that index as well. Again, ideally, you're never going to touch index.js either. There's not a whole lot of reasons to add to it, unless, of course, you're, again, either adding a Redux library or adding React Java or something that you have to put around app and for the greater context to pass down to all your app children. But in a basic level React app, you're not going to have to worry about that. You can just leave that as it is. As you can see, once I created an app folder, because Create React App actually isn't going to give you a folder for app, it's just going to have everything naked inside the source folder. I put the app CSS and the app test files into it, and I also put app.js into it as well. I actually changed the name of app.js to index.js. This is a convention that, again, you don't have to do. I like to do it in every single component. The JS file is going to be referenced as index.js. The reason to do that would be if you're importing, like say, when you're rendering, say, app and you want to add a child component in your JSX, you actually have to import the file so it knows what to render. And when you're writing that import statement, all you have to do is reference the folder and it'll automatically point to anything called index.js. So that's why I like to do it. Again, you can name your JS files after the component they want. They're named after, so I mean, that's personal preference again, but I think it dries up my code a little bit, makes it easier to read. So that's definitely an option available to you as well. As you can see, I also created a folder called components that I put all my components inside of. Not something you have to do again, but when you're using a Redux library especially, any component that's connected to Redux is actually referred to as a container. So common practice is to have a components folder and a containers folder so you can quickly go, okay, this isn't connected to Redux, so I know what folder to go to. It's just a way to make your app for a coder that's coming in who's not you and not building thing from scratch to be able to come in and navigate quickly and get to what they need to get to. It's basically a coder empathy kind of convention there. Lastly, as Jason said before, I was going to get into testing React app with Enzyme and Jest. I think that any good application should be tested at least a little bit. I think that makes an app stronger, especially as you're starting to build it out. If you got to scale it up, you definitely want to know if your new code is going to break old code. So you want to have some sort of a safety in there to help you out. Now the Jest library is an assertion library, like expect statements, that sort of a thing, should statements. That actually comes with Create React App as a dependency that's already built into the boilerplate, so you don't have to go get it. But Enzyme, you would have to download. There's an NPM package for that, and it's really easy to find with Google. But Enzyme specifically is what gives you access to a basic type of UI test, which is called a snapshot test. It gives you access to these two methods of rendering an application. The first render version is mount. That's the type of rendering that you would normally expect. It renders the top level component here, which I've indicated is loading, and renders any children that component has. It renders all the information inside of those children. It also renders all their children, all the information inside of those children, and so forth down the line, starting with your top level component. Now this is definitely something you would want to use if you're doing like maybe an integration test or something where you have to follow a path through a couple of children and you'd actually want all that information. However, with a simple snapshot test like this, where you're just taking a picture of the UI and then you're rendering it again when you rerun the test and matching the picture to make sure nothing has changed, you don't necessarily need all the information of all the children components if you want to break out the one component in isolation. And that's why Enzyme gives you access to shallow mounting as well. This will render your top level component loading. It'll render that there are children components, but it won't actually render all the information inside of those children, because you don't ideally need it. If I'm testing the loading component, I only need to look at that. I don't need to look at the children because I would have tests for all the children and I can test them by themselves. This quickens up your test runtime. As you can imagine, mounting all of your components, especially with a bigger app, will take longer, especially if you're doing it for every single one. And it's just getting rid of information that you don't necessarily need, especially if you're doing a unit test in isolation like this. It gives you the ability to take, like I said, a snapshot of that component, and then that saves it into a snapshots folder, which will live inside that component folder, and then you can re-render it whenever you run the test again, and it'll just compare to that snapshot, and it'll pass if it matches. Otherwise, testing syntax for Enzyme and Jest is pretty straightforward. We start with our describe block, where we talk about what component that we're going to be testing for. Anything inside this describe block is going to have access to global variables that you can declare. You can also use functions such as before each. There's also one called after each, where this will fire before every single test within this describe block, and the after each will fire at the end of every test, depending on what you want to do. Here in particular, I'm declaring a global variable called wrapper, and then I'm shallow rendering this component with all of these props being passed into it, and that's happening right before every test, so I just have a fresh version of that component. I don't have to worry, oh, if say this one test changed some information, that information is going to still be changed in my next test. I get to start fresh with every single test. That's definitely a great use for before each. After each would of course be for like any sort of cleanup type thing you'd want to do. Jest gives you the ability to use mock functions. If you're doing unit testing for functions where you just want to test one function by itself and you're not trying to, say it calls a secondary function here, I've declared an it block. This is one test right here. And then I describe what this function that I'm testing should do. And then I'm firing the function and then checking to see what happened. And then basically, I'm creating my mock event here and I'm passing it in when I fire the function. Just like with the binding that I described earlier, when you fire functions in a test, they have to be bound to the particular instance of the wrapper that you've rendered. So you have to declare the instance function first before you call that. This is the function that lives inside of the object of the member container. It's rendered. I call this function. I pass in my mock event. And then this function is supposed to call a secondary function called filter state. Now what I did is I declared a mock function using jest.fn, assigned it to this variable globally, and then I'm basically checking that this fired a function. I don't necessarily need to see what this function does because I would ideally have a unit test specifically for that function by itself somewhere else. All I need to check was that it was fired at all. So I just insert in a mock function and then I can check that the mock function was fired, and I know that this function is doing its job. And I know that it's taking a value from the mock event and passing it as parameters to the function that I called. And then this would be a successful test. Also, as I described, UUID before is a nice little node package that you can download that basically just whenever you call that function, it generates a random number. And I was using them to assign as keys to my components where I'd be rendering multiple times, like a card component or something like that, so they'd all have their own unique key. The issue with that is that my snapshot tests would fail. It would render one version of the component, then it would render again and try to match it to the old one, and that number is randomized, so it wouldn't be the same, it would fail. So Jest actually gives me the ability to mock out that function in particular. This globally and every describe block is going to get access to this mock. Anytime something called UUID is called, it's going to fire a mock function. Jest mock functions actually have the ability to give them a mock return value too. So I have every time UUID is called, fire jest.fn, which is going to return the number 1. So now that UUID key number in all my tests is just going to have the number 1. All my snapshot tests will pass. This is all the power of the Jest library. That's ultimately some basics of React. A strong bad picture? Yeah. And I think that, I hope anyway, that I was able to convey just a greater context. I know that's how I learned Jest, is to get like, not just this does this and that does that, but how they all relate to each other. So I was really trying to build the vivid panorama so you could just get maybe the basic concept of how React talks to itself and functions within its own environment. Currently, I'm looking for work, so if anybody's interested in contacting me, there's my GitHub, my LinkedIn, and my email address. Also, if you have any React questions or if you just want to talk about coding, because this stuff's real fun, you can definitely hit me up too. I'm always open. And I guess lastly, I would just like to see if anybody has any questions. I answer the best I can. Yeah.
Awesome.
Okay. Yeah.
Thank you so much. So if anybody hasn't worked with frameworks, that probably seems like a lot, you know. The way I always kind of look at things that are extremely complex like that is it kind of speaks to the power of them as well. So React here in Denver is definitely the most popular framework that I've seen, at least. If you're interested in enterprise, Angular is probably the framework for you, and Vue is the big like up and comer. It's GitHub stars are going through the roof. So hopefully next month will be our Vue. We haven't had a full-on confirmation of that, but hopefully next month will be Vue, and then Angular in June. Because we're the first Thursday of each month, 4th of July, we usually don't do meetup. People are too busy with holidays and that kind of stuff. So then Ember would be in August, is what we tentatively have planned right now. Let's see, want to thank Code Talent. This is their space here. They are a technical recruiting firm, so if you are looking for a job, I've worked with them in the past. They're super friendly, super nice guys. You can reach out to them, see if they might have anything, if you're looking for anything. Meant to do this at the beginning, but before we close out, anybody have any announcements? Anybody want to promote their own thing? Do a meetup? You have a meetup you like that you want to tell people? All right. Well, it was great to see so many new faces. This is probably the most new RSVPs we've had. Hope to see you guys come back next month for Vue. Great to see some of our long-timers. And thank you, Alex, for coming out. I appreciate it. One more round for Alex. Thank you, Justin, and my family for helping me set this up since I've got a bum leg right now. And thanks for coming out. You're more than welcome to kind of hang out, have another beer if you'd like. And thank you for coming. Appreciate it. Thank you. No, that was awesome. I appreciate it. I learned more from you than I did from my instructor.
Hey, thank you. That was good. Appreciate it. Yeah. Oh, sorry. My bad. Hey, sorry, remind me your name?
Jason.
Jason Ryan.
Oh, nice to meet you, Ryan.
Yeah. What's your background?
Let me get this stuff here real quick. Make sure that's